Honors Chemistry, and welcome to the Chapter 4 review packet. So, I already filled out the things that I was going to talk about, and then it turns out I did not hit record. So now I'm just going to go back and highlight a few things, because yeah, that happens sometimes. All right, so do note that Chapter 4, like I said before, is a quick turnaround. I do expect you to know these things, but I do feel like a lot of it's a review. So, Dalton's atomic theory, right? Make sure you know those principles and make sure you can discuss the things that are no longer true, right? Or the things that are not as true as originally written a very long time ago, right? Rutherford's gold foil experiment, right? The key thing is from Rutherford's gold foil experiment, we get the concept of the nuclear atom, right? That's where the concept of the nucleus comes from, right? Which is a huge development in nuclear theory, no, in atomic theory. The subatomic particles, I assume you know those things. Average atomic mass, right? So this part is key. And you don't use it much in middle school, but now conversion factors, obviously huge, right? So when we look at magnesium, for example, right, and magnesium says 24.31, right? When we think about what that says, right, that says one atom of magnesium has a mass of 24.31 atomic mass units. Yes, because going back to the fact that everything's a relationship, right? So every average atomic mass from the periodic table can be expressed that way, right? As in, that is the number of AMUs equal to one atom, okay? And that's going to be key because that same number does double duty in a couple of chapters when we get to the concept of molar mass, right? So same value, different scale, okay? Or same number. All right, moving along. Note that some of these ones that say to check your book and your notes, that's because I go over them and your book goes over them and you should be able to figure those out. That does mean when I check your review packet, if you don't have the right answer, you are going to get marked wrong, okay? Because there are certain things that I expect you to just be able to find. Common ion, do be mindful, right, that you are able to find the common ion formed by any given element based on its location in the periodic table, right? What group is it in? How many electrons does it need to gain or lose in order to fill its valence, right? So make sure you go back to that. Be as specific as possible for the identifying each type of element. That goes back to the lecture where I basically highlight, scribble all over the periodic table, identifying all the special groups that you should know, or sections of the periodic table that have their own special naming. So make sure you go and look at that and make sure you're clear on that. Properties of metals, nonmetals, and metalloids. So obviously metalloids are somewhere in between metals and nonmetals. When you write down that list of properties for metals and nonmetals, don't forget that last one, which may not have a lot of meaning to you right now, but is hugely important for everything that we're going to talk about for the rest of the school year, right? In that metals have a tendency to do what in a chemical reaction versus nonmetals, which have a tendency to do the opposite in a chemical reaction, right? So make sure you have that down in your answer. I will be looking for that. All right, where are the nonmetals, right? This part is important. Your periodic table doesn't have the line on it, I don't think, but you are welcome to doodle that on there because, again, you are welcome to add layers of color, right? You are welcome to add layers of markings. You just may not provide a written key on your periodic table. But we could draw a line on our periodic table right here, just like it is in your book, right? Where that would be the stair-step line that delineates metals, nonmetals, and metalloids, right? In that the things that touch the line, right? So silicon, germanium, arsenic, antimony, tellurium, right? Those would be considered our metalloids, right? And anything to the left would be a metal, anything to the right would be a nonmetal, right? With weird exceptions, right? Like aluminum, I think we should be clear as a metal, right? Life experience tells you that. Polonium, no, you don't have any life experience with polonium probably, but also a metal. Okay, other things to note. The concept of valence electrons is super important. I believe you talk about that in middle school also, right? In that the valence electrons are what determine the properties of any given element, right? How it's going to behave, what it's going to do, what it will react with, right? And then why do things react, right? also important, and I assume you could discuss that. This part's important here. So when we look here, everything is about gaining and losing electrons to fill your valence, or sharing, right, which we'll talk more about later. But calcium, right, calcium has 2 valence electrons to lose based on its group number, right? Chlorine needs to gain 1 electron to fill its valence, right, based on their respective locations on the periodic table, which means that if I had 2 chlorines, for every 1 calcium, calcium would have 2 to donate. Each chlorine would need to take 1, so the ratio of calcium to chlorine would be 1 calcium for every 2 chlorines. Yes, does that make sense, right? And that's really how all ionic compounds are formed, right? In the give and take and the balance of that, right? As in, metals will have a certain number of electrons to give, nonmetals will need a certain number, and the formula is going to be based on whatever the ratio is to distribute the electrons equally, right? All right, number 18. So we're going to complete this table. In order to do that, in order to determine the number of protons and electrons and average atomic mass, first we're going to look at the identity, right? So this one says chlorine. So we'd go look at a periodic table. We'd take the atomic number, and that would give us the number of protons, right? We'd look at this charge, which says -1. And if it's a -1, remember that all charge is the result of the gain or loss of electrons, yes? All charges are the result of a gain or loss of electrons. So in order to become a negative charge, that means we gained an electron, which is why this is 18, and the average atomic mass is copied from the periodic table, right? Next one, if we have sodium, we would go find sodium on the periodic table, write down its atomic number. We'd see that it has a charge of +1, which means that it must have lost an electron, right? And then likewise for the rest of those, okay? Here, we're writing the complete nuclear symbol, where A stands for the mass number, Z stands for the atomic number. Then in the upper right-hand corner, we have the charge, right? And then obviously the nuclear symbol is at the center of that, right? So if need be, go back and review your element names and symbols, because obviously you'll have to know those. All right, so thinking about defining these, so if we have a neutral atom, that already tells you there's not going to be a charge, which makes life convenient. Here I've given you the mass number and the number of neutrons, so that's when you need to remember that mass number is the sum of protons and neutrons, which will allow you to solve for the number of protons, right, and to figure out that this is polonium with a mass number of 209, right? Here in B, I've told you it's an ion, and it has 27 protons, which means that you'd go look at your periodic table, find the thing with an atomic number of 27, which happens to be cobalt, which then gives you your atomic number, right? In order to find the mass number, you would sum your protons and neutrons. In order to get your electrons, you would just look at the charge balance, right? In that if I have +27 for protons, -25 for electrons, that gives us an overall charge balance of 2+, yes? So forth and so on with the rest of these, right? All right, number 20. Chromium has 4 naturally occurring isotopes, and solve for the missing information. So if we look at the percent abundance, you'll see, oh, we got this one, and this one, and this one, and oh, I did not tell you that one. How do we figure that one out? Right, all percents must sum to 100, okay? Note that percents must sum to 100. Tuck that away because we're going to chat about it in just a minute. And so basically we could find chromium on the periodic table, which has an average atomic mass of 52. And then we just set up the whole equation, right? Subbing in an X for the piece we don't know, right? So here we have one isotope with its average abundance, with its percent abundance, an isotope, its percent, isotope, its percent, unknown isotope, and its percent, right? And then we would just solve for my AMUs. Number 21, right? Here we have 2 isotopes. One has a mass of this, one has a mass of that, and I would like the percent abundance of each. Now here it's important. As percents, the percents sum up to 100. When we do the math, though, we don't do the math in percents. We do the math in decimal form. The decimals sum to what? Right, 1. The decimals sum to 1, right? So I can use beautiful substitution, right, to solve for my percent abundance of each, making sure that I take a moment at the end to clarify which isotope has which percent abundance, okay? On the last page, this is just some fun stuff that incorporates review from last chapter that, yep, I do expect you to be able to do, right? For example, this whole mass of a volume of mercury, yeah, I expect you can still set it up correctly, and I will be checking for that, right? If it's not set up correctly, it'll be marked wrong. Using how much energy, so being able to use Q equals MC delta T, right? With all the units in the appropriate places, also going to be checked, right? F, this is F down here, right? Where basically we're just taking that concept of the atomic mass is equal to one atom, and then we're changing it from AMU per atom to femtograms per atom, right? And it's just, can you spot a conversion factor and use it? All right. Thank you for listening. Be good, and I will see you soon. All right. Bye.